In this video, we will be looking into the authentication in Backstage, how the authentication works in Backstage, and what are all the authentication providers available in Backstage, and so on. So, also we will look into how to use these authentication providers and how to configure them. So, the authentication system in Backstage serves two distinct purposes: sign-in and identification of users, as well as delegating access to third-party resources. So it is possible to configure Backstage to have any number of authentication providers, but only one of these will typically be used for sign-in. So with the rest being used to provide access to external resources. So identity management and the sign-in page in Backstage will only block external access when using the new backend system without setting backend auth, dangerously disable default auth policy in configuration. So even so, the front-end bundle is not protected from external access. Protecting it requires the use of the experimental public entry point. So you can learn more about this in the threat model. So Backstage comes with many common authentication providers in the code library. So some of those authentication providers are Auth0, Atlassian, Azure Easy Auth, Bitbucket Server, Cloudflare Access, GitHub, GitLab, Google IAP, Okta, OAuth2 Custom Proxy, OneLogin, VMware Cloud, and so on. So these built-in providers handle the authentication flow for a particular service, including required scopes, callbacks, and so on. So these providers are each added to a Backstage app in a similar way. So we will now look into how we can configure these authentication providers in our app config YAML. So we will each built-in provider has a configuration block under the auth section in the app config YAML. So, for example, if you want to configure GitHub, so you can do that with inside this auth section. You can add the providers here. So you can look for the documentation for a particular provider to see what configuration is needed for each individual provider. So the provider's key may have several authentication providers if multiple authentication methods are supported. So each provider may also have configuration for different authentication environments, let's say development, production, and so on. So this allows a single auth backend to serve multiple environments, such as running a local frontend against a deployed backend. So the provider configuration matching the local auth environment setting will be selected like this. So using an authentication provider for signing in is something you need to configure both in the front end app as well as the auth backend plugin. So for more information on how to configure the backend app, you can check the sign in identities and resolvers documentation. So the rest of this discussion will focus on how to configure sign in for the front end application. Sign in is configured by providing a custom sign in page app component. So it will be rendered before any other routes in the app and is responsible for providing the identity of the current user. So the sign in page can render any number of pages and components or just blank space with login or logic running in the background. So in the end, however, it must provide a valid backend, a backstage user identity through the on sign in success callback property. So at which point the rest of the app is rendered. So if you want to, you can use the sign-in page component that is provided by the Backstage core components library, which takes either a provider or providers, a list of providers. A property is an array of sign-in provider config definitions. So let's see how to configure the GitHub in the app.tsx. Let's go to packages, source, app.tsx. Here we can import the GitHub or the API reference like this. And let's import the sign-in page component. Import sign-in page from Backstage core components. And after that, inside the create app function call, we need to specify components sign-in page like this. So we already configured GitHub here. This is how we configure the authentication provider. So if multiple, you can configure sign-in to use a redirect flow with no pop-up by adding the enable experimental redirect flow flag in the app config. So you can also use the providers property to enable multiple sign-in methods, for example, to allow guest access. So if it is just a single provider, we'll just use provider equals like this. Here we can give title as GitHub, sh. So if it is a single provider, you can give it like this. So you can configure sign-in to use a redirect flow also. So you can also enable use the providers plural property to enable multiple sign-in methods like this. So if you want to add a guest provider also, you can do it with this like this. So, so in this example, you have both guest and GitHub sign-in options. So this is helpful for non-production, but in production, you will most likely not want to offer guest access. So let's start and see how this looks. Once the application starts, we will go to our browser. I think the sign-in page is already imported. We don't need this duplicate import. Let's now go to the browser. And let's try to log out and log in again. So now we have guest also included. We can enter as guest and we can see all the things. Perfect. Or we can log in with GitHub. All right. Uh, so you can easily use the information from your config to help conditionally render the provider also. So basically, how we can do that is what we will look into next. So we can go back to our source code. And if you see in this config here, if I want to get the config information, I can do it inside here. So if I just want to return something like this, I can wrap this inside the brackets and return this part. And if I want to do some logic to calculate whether I need to add this property or not, I can get the information, the config that is there in the app config YAML. If you want to get it, we can do it this config API, use API of config API ref. We need to import this config API from use API from port plugin API. We have this config API reference, use API, like this. We can import and use this use API and then config API reference. This is how we get the config that is configured in the app config YAML. So after that, if we have some condition, let's say config API dot get string. So this property gives us the specific value configured from the app config. If the environment configured is development, we can return all of this. So we have the config like this. And if it is not development environment, we will just return only the GitHub provider. We'll not configure the guest provider. We'll just use GitHub provider alone. This way it will show only the data provider if it is production environment. If it is development environment, it will show both guest and GitHub. So if we go back to app config, you can specifically configure auth.environment variable here. Use production. And let's see the UI. So we have only GitHub provider. You can only sign in with GitHub. So the error was due to a misconfiguration. So as you can see here, you can see only GitHub if the configuration is production. So let's go back to the code, and in the config we will change it back to development. Let's go back to the browser. Let's log out and see if the guest is allowed. Guest is allowed. Perfect. And some auth providers are so-called proxy providers, meaning they are meant to be used behind an authentication proxy. So example of these are Amazon Application Load Balancer, Azure AC Auth, Cloudflare Access, Google Identity Aware Proxy, and OAuth 2 Proxy. So when using a proxy provider, you'll end up wanting to use a different sign-in page, as there is no need for further user interactions once you have signed in towards the proxy. So all the sign-in page needs to do is call the slash refresh endpoint of the auth providers to get the existing session. So which is exactly what the proxy the sign-in page does. So the only thing you need to do to configure the proxied sign-in page is to pass the ID of the provider, like we will see now. So if I want to configure proxy authentication, we can do so with sign-in page. Instead of this, we just need to use something like this. Sign-in page. We'll just need to return something like proxied sign-in page with all the props, and then provider, whatever the name of the provider is. Let's say if I'm choosing Amazon ALB, I can use it like this. So if the provider in auth backend expects additional headers such as X provider token, there is now a way to configure that in proxy sign-in page using the optional headers property. So if I want to do that, I can go with this. After providers, we will have to just use headers. Whatever headers you want to put, you can put it inside this. Some key and then some value. And headers also can be written in an async manner. So if it has to be asynchronous, then we can do it the other way also. So if it's async, we should do it with headers as an async function that returns these headers. Let's say we will have another function inside here that will have some value get from the sum function. This is just a placeholder function, and then we can return whatever value is returned from that sum function. So this is how we can configure an async header function. Let's comment out this as well, as we will not be using that. So the downside of this method is that it can be cumbersome and to set up for local development environments. So as a workaround for this, it's possible to dynamically select the sign-in page based on what environment the app is running on, and then use a different sign-in method for local development if one is needed at all. So depending on the exact setup, one might choose to select the sign-in method based on the process env node env environment variable. So by checking the host name of the current location or by accessing the configuration API to read a configuration value. So for example, if we have development environment, we will use both guest and GitHub providers. And if it is production, we might be using something like this. Proxied sign-in page with properties. Let's say GCP IAP. This I'm going to comment out for now. So when using multiple auth providers like this, it's important that you configure the different sign-in resolvers for so that they resolve to the same identity regardless of the method that is used. So if you want to, next thing is if you want to use the authentication capabilities of the repository picker inside your software templates, you'll need to configure the SCM auth API. So alongside your authentication provider, you should configure the SCM auth API. So to get the data from the repository picker. So it is an API used to authenticate towards different SCM systems in a generic way based on what resource is being accessed. To set it up, you'll need to add an API factory entry in package API.ts, APIs.ts. So the example we'll be showing will set up the SCM auth API for an already configured GitLab authentication provider. So for that, we will just show an example of configuring this. So let's go to packages, app, source, apis.ts. So here we would create API factory. So this is what we will configure, just like this. Any API factory you can configure like this. So if I have to create a new API factory, I can just do like this, API factory. We will choose something like SCM auth API reference. Dependencies will be GitLab auth API. And then the factory will be a callback function for GitLab. And we will give the GitLab auth API here. So if this factory is configured, we will have access to the repository picker and so on. So in case you are using a custom authentication providers, you might need to add a custom SEM API implementation also. So for now, let's comment out this portion. So for plugin developers, the Backstage frontend core APIs provide a set of utility APIs for plugin developers to use, both to access the user identity as well as the third-party resources. So for plugin developers, there is one main touch point for accessing the user identity. So the identity API exported by Backstage core plugin API via the identity API reference. So the identity API gives access to the signed in user's identity in the front end. So it provides access to the user's entity reference, lightweight profile information, and a Backstage token that identifies the user when making authenticated calls within the Backstage. So when making calls to backend plugins, we recommend that the fetch API is used, so which is exported via the fetch API reference from Backstage core plugin API. So the fetch API will automatically include a Backstage token in the request, meaning there is no need to interact directly with the identity API. So for accessing the third-party resources, how do we do that? So a common pattern for this is so a common pattern for taking or talking to the third-party services in Backstage is user to server requests, where short-lived OAuth access tokens are requested by plugins to authenticate calls to external services. So these calls can be made either directly or the services or through the backend plugin or a service. So by relying on user to server calls, we keep the coupling between the front end and back end low and provide a much lower barrier for plugins to make use of third-party services. So this is in comparison to, for example, a session-based system where access tokens are stored on the server side. So such a solution would require a much deeper coupling between the auth backend plugin, its session storage, and other backend plugins or separate services. So a goal of Backstage is to make it as easy as possible to create new plugins, and an auth solution based on user to server OAuth helps in that regard. So the method with which front-end plugins request access to third-party services is through utility APIs. For each service provider, we have these utility APIs. These are all suffixed with auth API reference. For example, GitHub auth API reference, GitLab auth API reference, and so on. For a full list of providers, you can see the documentation reference for core plugin APIs. So if you have to implement custom authentication providers, you can follow some guidelines. There are generic authentication providers for OAuth 2 and SAML, SAML, simply SAML. So these can reduce the amount of code needed to implement a custom authentication provider that adheres to these standards. So Backstage uses Passport, which is the library under the hood, which has a wide library of authentication strategies for different providers. You can see the Add authentication provider documentation for details on adding a new passport supported authentication method. So if you have to know about custom SCM Auth API implementation, so the default SCM Auth API provides integrations for GitHub, GitLab, Azure, and Bitbucket, and is created by the code SCM Auth create default API factory. This gives us the full functionality for accessing the uh, SCM authentication APIs. If you require only a subset of these integrations, then you'll need a custom implementation of the SCM Auth API. So it is an API used to authenticate different SCM systems generically based on what resource is being accessed and is used, for example, by the scaffolder, software templates, and catalog import plugins. So the first step is to remove the code that creates the default providers. So in the API.ts, if you go to the top, this is the SCM auth. It's a generic implementation that creates the default providers. So at the end, also API factories, you can remove at the end. You can see this create default API factory. So this one, you can replace it with something like uh, this dependencies, GitHub Auth API, GitLab Auth API, and so on. So if I have to implement this same thing, I can just for GitHub APIs, I can do it like this. Dependencies, I will choose GitHub auth reference. This we need to import from core plugin API, and GitHub auth API, we will have to return for GitHub. And this config, we should use GitHub auth API. So if you use any custom authentication integrations, a new provider can be added to the API factory. So here, so this is an array. You can add multiple API factories inside of here. So let's comment out this part. So the first step is to create a new authentication reference, which follows the naming convention. If it is a custom authentication provider, if you are creating, so the first step is to create a authentication reference, which follows this convention XXX auth API reference. And the example below here in this is for a new GitHub enterprise integration, which can be defined either inside the app itself, if it's only used for this purpose, or inside a common internal package for APIs, such as internal slash APIs and so on. Let's do that with this const GitHub enterprise auth API reference. We'll just use API reference OAuth API. File info API, session API. So we need to import these. All these are from core plugin API. And this one is going to be equal to, and then we will do create API reference with the details, ID as internal auth GitHub Enterprise. And this new API reference will only work if you define an API factory for it. For example, we can create a factory like this. Create API factory. Inside of here, we will have auth API reference. Dependencies will be a list of dependencies. Discovery API from core API, plugin API. This is from core plugin API. Auth request API. Auth request API reference. Then config API. It will be config API reference. And then we will define factory. Which will again be a callback function which accepts discovery API, auth request API, config API, and then which returns GitHub authentication structure with the following configurations. And this we need to import. Config API, discovery API, auth request API, and then we will have providers. This one we will give a name to the provider, and we will give the title, say GitHub Enterprise. And icon, we can give something like null. And default scopes, read user. These are the properties in the OAuth specifications. And we can specify the environment on which this works. Config API, but get optional string or environment. This way you can create a custom factory. The new API reference is then used to add a new provider to the API factory. So this is how we create a factory. So if I have to use this newly created API factory, I can do something like this. Create API factory. Along with the other API factories, we can use this as well. Let's use CM auth API reference. Dependencies will be all this. GHG auth API reference. We'll have GitHub auth API, which will be GitHub auth API reference. And we'll specify the factory as another callback which has GitHub auth API and GitHub Enterprise auth API as input parameters, and then it returns SCM auth. Merge these two into CM auth for GitHub. We'll be using GitHub auth API here, and we will have the other thing merged. The SCM auth for GitHub. This time we're going to use GHE auth API, which is the enterprise auth API, with the host configuration changed. Like this. We need to import this for plugin API reference. So this is how we create a custom API. Finally, you also need to add the configuration as another provider to the auth backend using the provider ID, which in this case is GHE. So in the provider factories, basically in the provider factories in auth backend, do import provider from Backstage plugin auth backend, and then we can do, so basically this thing has to go inside auth.ts, which will be there in the backend. It is backend source. And if we have plugins, inside the plugin, we will have that something like this. Provider factories will be something like this. CHE providers.github.create. This way we will add these to the plugins, backend plugin that we add. So let's comment out these portions. We will use it when we implement something like this later. So the next thing we need to look into is configuring how to configure the token issuers. So by default, the Backstage authentication backend generates and manages its own signing keys automatically for any issued Backstage tokens. So, however, these keys have a short lifetime and do not persist after instance restarts. So, alternatively, users can provide their own public and private key files to sign issued tokens. So, this is beneficial in scenarios where the token verification implementation aggressively caches the list of keys and doesn't attempt to fetch new ones, even if they are encountered, if even if they encounter an unknown key ID. So to enable this feature, you need to add the configuration to the auth section in the app config file. App config YAML. Let's go to app config. So inside the auth section, we will have to give the providers if need be. So if there is a static provider, we can actually give something like this. Provider as static. This will have to have keys that needs to be used for signing. Key ID will use primary key here. So we'll have to specify the public key file and private key. And then the algorithm we want to use. This is actually optional. And we can have multiple keys like this and so on. So let's comment out this portion as we are not going to use this. So the primary key should be stored in the PKCS8 format. The public key should be stored in the SPKI format. You can generate the public or private keys pairs using OpenSSL and ES256 algorithm. So by performing the following steps, you can do that. So to actually generate these keys, you need to generate a private key using ES256 algorithm. You can do something like this: OpenSSL cparam name primary 256 v1 then key output to private.ec.key. So to convert it into PKCS number 8 format, so this is for ES. So this is to generate a private key using ES256 algorithm, this command. And the next step is to convert into PKCS8 format. For doing that, you need to use this command. OpenSSL PKCS8 inform PEM out form em no crypt. In key is private.ec.key and out is private key. So next thing is to extract the public key. How do I extract public key from this key pair? Extract public key. We can do something like this. NSSL EC inform em outform em public out. In key is private dot key. Out is public dot key. So this is how we can generate these certificates and keys. So this is how the authentication in Backstage works.